Hello everyone! Welcome to the next video in our series for getting ready for your study guide for your final. Alright, last class we left off with 16C. Alright, so we're going to pick up from there, okay? Alright, so we've got the balanced reaction sitting up on top, and 16C says if I could drop 6 molecules of MgSO4 in a bunch of KNO3, and it doesn't really specify how much, so just a bunch of KNO3. How many molecules of K2SO4 can I make? And I don't like the word molecules. I would actually call this an ionic compound because K2SO4 is ionic. I'd probably just change that. Guys, typo. Let's call those formula units. How many formula units of K2SO4 can I make? Okay, so how many formula units of K2SO4 can I make? Alright, so we're starting you off with MgSO4. We're starting you off with 6 molecules here. And I don't like molecules. Gosh dang it. These are formula units as well. Okay, so if I started you with 6 formula units of MgSO4, and I just dump it into a whole bunch of KNO3, they are asking you to figure out how much K2SO4 can you make. So over here, right here. Okay. Alright, so the ratio between those two is 1 to 1. So if you are reacting 6 formula units of MgSO4, if you look at their ratio, see how there's nothing in front of here and there's nothing in front of there? If you have a 6 right here, what is this one going to have to be then? A 6 as well. So I'm not doing any math. The answer is 6 because its original ratio was 1 to 1. So if you had 6 formula units on the left, you will have 6 formula units on the right because it originally was a 1 to 1 ratio. Alright, let's go to the next question, part D. Part D says if I have 7.50 grams of KNO3 and an excess of MgSO4, what that means is that you have a lot of MgSO4 and it won't run out. Okay, so that's not actually part of the problem, that information that they gave you. And I produce 3.20 grams of K2SO4. What is my percent yield? Okay. So in the way that the problem was written, they said, if you have 7.5 grams and you make this much, what's the percent yield? I want to make sure you guys understand that the information that they gave you right here, this piece right here, the 3.20 grams, this is your actual yield because it was given to you in the problem. What you guys need to do is you need to come up with the theoretical yield. Theoretical yield is how much you were supposed to make. Alright, the only way that you can get theoretical yield, how much you're supposed to make, is with math. So when you think about theoretical yield in general, I want you to think math. Alright, so we got to figure out that theoretical yield. We were given 7.50 grams of KNO3. And what we're going to do is we're going to figure out how much K2SO4 we're supposed to make with that value. So coming up here, if we're looking at everything up here, they gave you 7.50 grams of this, and they're asking you to figure out how much of this were you supposed to make. So this is kind of the pathway we got to think of in our head. Ignore that 6. Remember, we were just using that in the previous sample. So it looks like the ratio between KNO3 and K2SO4 is actually, if you look carefully, is a 2 to 1. 2 to 1 ratio, so just watch that. Alright, so this is just a traditional stoichiometry problem. I can guarantee that what you're going to have is this many steps because we need to throw the mole ratio in there, right? So you're starting with mass, we're going to go from mass to moles, get the mole ratio, and then end with mass again. Alright, so in this first spot, molar mass. Second spot, mole ratio. At the very end, molar mass again. Alright, it's always the same pattern. Alright, so let's get the molar mass of that KNO3. So potassium is 39.1 grams, nitrogen is 14.0 grams, and oxygen is 16.0 grams, but you've got 3 of those. Alright, let's do our math. I've got 101.3 for the total mass here. So where should I put that mass? Always follow your units, so this is a good practice. You've got grams here, so you have to have grams down here. How many grams are we going to put down there? 101.3, because that's its molar mass. Molar mass of 1 mole. That's what molar mass is. 1 mole of KNO3. Oh, someone got 101.1. I'm checking my math. Yeah, I got 101.1. Thank you for checking that. Whoops. Whoops. Good job. So 101.1 and 0.1. There you go. All right. So coming back to that mole-mole ratio, look back at that balanced reaction. And the way that we always do this is we always cross-cancel with the same material. So this is moles of KNO3. That means we need to cross-cancel with KNO3 in the mole-mole ratio. So when you're looking at that balanced reaction, the KNO3 has a 2. So I'm going to follow KNO3 and I'm going to put that 2 right here because that was the coefficient on KNO3. So this is 2 moles of KNO3. Now we're trying to get to figure out, we're trying to get to K2SO4. So looking back up here, K2SO4 in the original balanced reaction didn't have anything in front of it, no coefficient. So that means you only have 1 mole of K2SO4. So I'm going to stick that on there. All right, there's our mole-mole ratio from the balanced reaction. The last step is, if you look at everything that's crossed off here, the last step is to get to the mass of K2SO4 because that's what we want to know. We want to know how much K2SO4 we're supposed to make in mass. So the very last step, we're going to use molar mass of K2SO4. So here we go. Potassium is 39.1, S is 32.1, and oxygen is 16.0, but you've got 4 of those and you've got 2 of those, so be careful. Okay, I got 174.3. Does anybody confirm that? Because I feel like I've been doing some bad typos. You guys good? Yeah? Alright, great. Okay, so this is the mass of 1 mole. So remember, we're always cross-canceling here, and here you are with 1 mole sitting on the top. You have to cross-cancel with moles down here. See, over here we cross-canceled grams, but here you need to cross-cancel moles. So how many moles should I use if I am trying to use molar mass? 1 mole. 1 mole, and this is K2SO4. This is his molar mass. Alright, so I'm going to put the 174.3 grams on the top, and we just cross-canceled those moles there. Alright, so when you're looking at the problem, remember I ignore ones. Anything on the top is multiply, and anything on the bottom, that's a denominator, and denominator means divide. So this will be 7.5 divided by 101.1 divided by 2 times 174.3. Okay, on the calculator, I get 6.46513, and it keeps going. But you're going to want to round that. Mole-mole ratios don't count, so this won't count for sig figs, this doesn't count for sig figs, and that doesn't count for sig figs. So you have 3 versus 4 versus 4. What should you have? 3. Always go with the lesser amount. 1, 2, 3. Do you need to round that 6 up? Yes, so this will be 6.47 grams of K2SO4. This is what you were supposed to make. You see how we calculated that with math. Theoretical yields are calculated with math. Alright, so we're still looking, we didn't quite answer the problem, we're still looking for percent yield. This was your actual mass, and this is your theoretical mass. So this is a good review. Percent yield is just what you got divided by what you should have got times 100. It's very similar to figuring out what your grade is on a particular assignment. So what we got was 3.20 grams. What you should have got was the 6.47 grams. So let's just times that by 100, and that gives us percent yield. Divided by 6.47 times 100. All right, looks like we got 49.459%. Now I'm going to go with 3 sig figs again. 1, 2, 3. I'm going to round that last 4 to a 5, and that's your percent yield. So you only got 49.5%. How far off were you from your target? Your target is always to get 100%. You're supposed to get 100%, right? How far off was this measurement from that 100%? Yeah, guys, so if you take 100 and you subtract 49.5, do you realize what that is? You'll get 50.5. You were off by 50.5%. Do you want to know what that is? That's your percent error. That's the difference between yield and percent error. It's the difference from the 100%. You were supposed to get 100%, but you didn't quite cut it. All right, anyway. Okay, moving on to 16D. Oh wait, that was 16D, I'm sorry. 16E. Okay, so on this one, they said that they gave you 5.63 grams of KNO3 and 5.63 grams of MgSO4. And they want to know which one is your limiting reagent, what's your theoretical yield for K2SO4. So we're trying to get to K2SO4. This is what they want to know about. How much is leftover excess? What if I actually only made 1.35 grams of this? What would be your percent yield? So lots of good questions here. All right, this is where you have a limiting reagent problem. Anytime we give you two quantities and we're asking you to determine the maximum amount you can make, that's called your theoretical yield. Or if we're asking you about what is excess, what's left over, this is the type of problem that you would have right here. And can I give you guys a big fat hint? So if you're watching this vodcast at home, you better be thanking your lucky stars that you listened to this part. This is what your written problem will be. Just like this. Okay? Just like this. All right, so you're lucky that you're privy to that information. All right, here we go. All right, so I'm going to redraw the balanced reaction just so that we can look at it and kind of analyze it a little bit better, okay? So I'm pretty sure you needed 2 of those for every one of these. And that's going to make K2SO4 and MgNO3 2 to balance it. Yeah, it's all balanced. And okay, so the way that I like to do it, and I do this all the time, I think you guys have seen me do this, I will list the information provided underneath the balanced reaction just so I can kind of figure out what the heck they want me to do. So they're giving you 5.63 grams of this, 5.63 grams of this as well, and they're asking you for how much K2SO4 can you make. This is going to require 2 problems. In the first problem, you're going to go from KNO3 to this, but then in the second problem, you're also going to go from MgSO4 to the same thing. So you're doing this twice. All right? So 2 problems should be set up here, and they will all look the same. Mass to moles, mole-mole ratio, ending with mass. Mass to moles, mole-mole ratio, ending with mass. And they will both be ending on the same thing, K2SO4. All right, let's get started. In the first one, we're starting with mass, so I'm going to get its molar mass, and I think we already did that up here, didn't we? Yeah, it's 101.1 grams per mole. This guy right here is 101.1 grams per mole. So where do I put the mass? Where do I put 101.1 grams? Yeah, you guys following that? You always, it's a trail. It's always the same trail. So grams has to cross-cancel grams. So I'm going to put 101.3 grams on the bottom. That's equivalent to 1 mole of KNO3. All right, what's the mole-mole ratio between KNO3 and K2SO4? Look at your coefficient. Yeah, you see how there's a 2 in front of your KNO3? So you see how I have KNO3 here? I have to follow that. I'm going to put the 2 moles of KNO3 down here from the balanced reaction, and I'm trying to go to take K2SO4, and there's nothing in front of that K2SO4, so that means that's only 1. Yeah. What'd you get? Oh, why am I doing 101.3 again? Why am I really stuck on that 3? Thank you. 0.1. Sorry about that. Glad you caught that. Why am I stuck on that? That's so weird. Alright, let's get the mass of the K2SO4. I think we've already done that. Ooh, yay. Okay, so here it is. The mass of K2SO4 is 174.3, so I'm going to go ahead and use that again. So 1 mole of K2SO4 is 174.3 grams. Okay, so there's that first problem. Let's go ahead and do the next one, might as well. So here's the MgSO4. Mg has a molar mass of 24.3. Sulfur has a molar mass of 32.1. And then oxygen has a molar mass of 16, but you've got 4 of those. All right, let's do that. Okay, I got 120.4. 120.4. Sound about right? Alright, so I'm going to follow the mass here. Grams, cross-canceling grams. I'm going to put 120.4 grams down here, and that's equivalent to 1 mole of MgSO4. Looking back at my balanced reaction, it looks like there's a 1 to 1 mole ratio between MgSO4 and K2SO4. So then we'll just end it here with the molar mass of that K2SO4. So let's finish it off. 1 mole K2SO4, and it's still 174.3 grams. Okay, so let's go ahead and solve both of these. Anything on the top is multiply, anything on the bottom is divide. Ignore your ones. So I'm looking at that first set. 5.63 divided by 101.1 divided by 2 times 174.3. Up here, my answer is 4.85316. It keeps going. Let's get the bottom one here. 5.63 divided by 120.4 times 174.3. Okay, on the bottom one, I got 8.1504, and it keeps going. All right, check on your sig figs. It looks like we had 3 sig figs on our molar mass, or I mean on the masses, and then all the molar masses have 4. So you should probably round these to 3. So let's do that. 1, 2, 3. You don't need to round the 5, so you created 4.85 grams here. 1, 2, 3. Don't need to round that 5, so this is 8.15 grams. All right, guys, why do you have 2 answers? Because you had 2 reactants. One of them ran out. Okay, and it limited the maximum amount that you can make. So which one, the KNO3 or the MgSO4, ran out, and how do you know? The way that you can tell is that the problem that created the lesser amount, this one right here, this guy ran out. The KNO3 is gone because he produced the lesser amount. So this guy is completely gone. He is what we call your limiting reagent. Limiting reagent. That means that this reactant was in excess. We had more than what we needed. We used some of him, but we did not use all of him. This also means that the 4.85 is the maximum you can make. All right, this is the max you can make. That is sometimes called your theoretical yield. This is how much we should have made in theory. Now, we did not make all of this 8.15 grams. What that means is that the MgSO4 is in excess. We used some of it, but we did not use all of it. So the problem continues, and it wants you to figure out how much excess is left over. We've identified that MgSO4 is in excess. We used some of this 5.63 grams to create the 4.85 grams, but we did not use all of it. So we can actually calculate exactly how much MgSO4 we used. It will be a value that is less than 5.63 because it'll represent how much we used, because we did not use all of the 5.63 grams. Alright, so what I'm going to do is I'm going to start with the 4.85 grams of my theoretical yield for my, what was this, K2SO4. And I am going to calculate how much of the MgSO4 I use, because I use some of it, but not all of it. And the best part about doing this problem is that I am working backwards, and I already did all of my molar masses. The molar mass of my K2SO4 is 174.3 grams. So again, what I'm doing is I'm calculating how much MgSO4 I actually used, because I did not use all of it. Alright, the ratio between K2SO4 and MgSO4 is 1 to 1. Okay, and let's get the mass of my MgSO4. That is 120.4 grams. .4. Alright, the answer to this will be the amount of MgSO4 that I actually used. To figure out excess, what would you guys have to do? Subtract from the initial value, 5.63 grams. Alright guys, I'm going to pause it here. People are packing up and leaving. I hope it helped.